Alright, so now we're talking about this word problem, and it wants to know the maximum height. So when I'm talking about the maximum height of an object, I'm looking for the vertex. Okay, so these two are talking about the maximum height. So both of these questions are talking about the vertex. It wants to know in A the actual height, so that's going to ask for the y value of the vertex, and in B how long it took to get here. So let's start with the maximum height. So I'm going to go through and try to find my vertex. And remember, to find the vertex, to find the x value, you do opposite b over 2a. And to find the y value, you plug in. Okay, so I would do opposite b over 2 times a, which gives me 1.5. That's how many seconds. So I can go ahead and answer this question because how long it takes will be the seconds. So this is how long it takes to get to that maximum height, 1.5 seconds. This wants to know what the actual height is. So what I would do is I would take 1.5 and plug it in now. So I've got h of t is equal to negative 16 times 1.5 squared plus 48 times 1.5 plus 64. And the height is 100 feet. Okay? So now it says the equation for this. So how long does it take the object to stay at or above 60 feet? So it's saying, like, how long would it take to hit, I don't know, here. So because it's talking about a height here, when it's talking about 60 feet, I'm going to put 60 in for h and solve for t. So when I'm solving my problem, it's 60 is equal to negative 16t squared plus 48t plus 64. So it's not equal to 0 because 0 is the ground. And it wants to know how far is it going to stay above 60 feet, not the ground. So I would solve and make this equal to 0 so that I can start solving my quadratic. So when I do that, I get 0 equals negative 16t squared plus 48t plus 4. And now I'm going to use my quadratic formula. X is equal to opposite b plus or minus square root b squared minus 4 times negative 16 times c all over 2 times negative 16. So that's negative 32 on the bottom, and then when I do what's under the radical, I get 2,560. So now I'm going to take the square root of, oops, this thing is sensitive today. Now I'm going to take the square root of plus or minus, take the square root of 2,560, and it gives me 50.596. Now I'm going to add and subtract across the top and divide by negative 32. So when I do that, I get these two answers, and again, this one doesn't make sense because time can't be that, so it's this many seconds. And number 12, find the zeros. So I could use the quadratic formula, but I would have to FOIL this out, and that's not fun for anybody. So, and when you did FOIL, you would have to do x minus 5 times x minus 5, then FOIL that and get it equal to 0. And I don't want to do all that. I can just solve for x using the square root method. So because this whole thing's being squared, I can't move the 5 yet. I have to undo the square first. And so when I take the square root of both sides, remember you get plus or minus whatever the square root of that is. In this case, it's 7. So I get x minus 5 equals plus or minus 7. So I would add 5 to both sides. And I get x is equal to 5 plus or minus 7. Well, 5 plus 7 is 12. 5 minus 7 is negative 2. So 12 and negative 2 are your answers. Same thing on number 13. I could use the quadratic formula, but again, I could just use the square root method and solve for x. So I'm going to add 108. And when I do that, I get 3x squared equals 108. Divide by 3 this time because 3 is not being squared, so I can move it. And I get x squared equals 36. Take the square root of both sides, and I get x is equal to plus or minus 6. So I've been making you write it as 6, 0, negative 6, 0. Same on the one before that. But if you just wrote x is 6 and negative 6, I would have accepted that as well.